Okay, so we're going to start by plotting some angles in standard position. And here's how it works. In standard position, that means we're going to be on an XY axis. The origin is always going to be the vertex in standard position, okay? And one side of the angle is always going to point straight to the right on the x-axis, due east, right? And then the other side is going to, so this side is called the initial side. Okay? And then we've got the other side of the angle is going to be called the terminal side, and that's going to swing around like a clock, okay? So if I wanted a 45-degree angle, it looks something like that, okay? And the idea with this is that we can go around as far as we want, and you can actually get angles that are more than 360 degrees. You can also do negative angles if you go in this direction. So the positive direction is that way. So we're going counterclockwise for the positive direction, okay? So 45 degrees, I'm not going to measure this out with a protractor, but I'm just kind of eyeballing it. It would look something like this, okay? And I'd want to actually show my little arrow to show how I've gotten there, because I could have swung that around in the negative direction, okay? So there's a 45-degree angle sketched in standard position. If you go to this website, if you scan that, then you can play around with it's just something like this, where you can twist around the terminal side. This is called the terminal side. You can swing it around and see what the different angle measures would be. Okay, so it wouldn't make sense to have a 400-degree angle drawn, say, in a triangle. It's not going to work, but we can put one in standard position, and this has some real-world applications. So always going to start like that, okay? And then what I'm thinking to myself, I'm going to go around, since it's a positive angle, I'm going to go up, okay? And if I get to right here, that's 90 degrees, right? Now I'm at 180. Every quarter turn is another 90 degrees. So I'm at 180, this would be 270. And I'm going to kind of spiral this around. So right now I'm at 360, okay? So I'm at 360 right now, and I'm thinking, okay, 360, I got another 40 to go, so I'm just eyeballing the 40 degrees. I could get out a protractor if I wanted to be accurate, okay? It's going to look something like this. So it looks a lot like a 45-degree angle because, I mean, it's 40 degrees above the x-axis. But that's why I put this spiral in, to show that I've gone around more than 360 degrees. And this is what a 400-degree angle would look like in standard position, okay? All right, let's try plotting a negative angle. So I'm still starting same way as always, okay? But rather than going up, I'm going to swing down. So I'm going to swing down about 45 degrees. And again, just eyeballing this in. But I want to show that I went that direction, okay? So this would be a negative 45-degree angle then, okay? Which, again, you couldn't draw in a triangle. But when you're using this hands of a clock idea, we can put it in standard position, okay? So coterminal angles are angles that share the same terminal side. Okay, so I've got three different angles. You can't see the bottom side very well, but got three different angles that look identical here. Okay, but they're going to be coterminal angles, but they're going to be different measures. Let's say that this is a 40-degree angle right here. Okay. So that's going to be the same. It's going to look the same as a 400-degree angle. So let's say I've got it. It has this same terminal side, but let's say we went around a full 360 degrees and then another 40 degrees. So those are coterminal, but because they look identical, but the way you got there is a little bit different. So this would be a 400-degree angle because it's just 360 plus another 40, right? Or we could go in the negative direction. Let's say we started like this and we swung this hand of the clock around that direction, in the negative direction. We could go this way. Okay, and then if I'm thinking about that, let's see, I went 90, 180, 270, and if this is if this is a 40-degree gap right there, then in this last part, I would have had to gone another 50 past 270. So it's 40 degrees shy of 360 is another way to think of it. So that would give me negative 320 degrees, right? 40 degrees shy of a full 360 degree turn in the negative direction. Okay, so these are all coterminal angles here. Okay, let's say you're asked to find all angles that are coterminal with a 72 degree angle. So you can take a 72 degree angle and just do an extra spin, right? I mean, this is a 40 degree one, but you could just do an extra spin. So like, here's a 70 degree angle. Let's say 72 degree, I mean. If I wanted something that's coterminal around with that, I just have to do another spin in the positive or the negative direction. Or I could do 2 or 3 or 4 spins, okay? So the way I'm going to write that, I'm going to take my original angle, and I'm just going to add 360 degree turns to that of the clock, okay? So I said plus 360n. That's with the understanding that n is an integer. Okay, so n could be positive 1, 2, 3, 4 or whatever, or it could be negative 1, 2, 3, 4, and that just means I'm doing a full spin, some multiple of full spins either in the positive or negative direction. Okay, and if you wanted to make an actual list, you could start plugging in 1, 2, 3, 4, but it's an infinitely long list, right? So this is a nice, concise way to list all of them. Okay. Okay, so on this next page, we're going to be asked to find one positive and one negative angle that are coterminal with a 31 degree angle. So, you know, I could say all of the angles would be 31 degrees plus 360n. And you can start with that. But if I want to actually list a positive and a negative one, I'm just going to add a one full spin in the positive direction. I could have added 2 or 3 or 4, but I might as well do the least amount of spins that I can. That's going to put me at 391 degrees. So hey, there's a positive angle that's coterminal with 31 degrees because it's a full 360 away. Okay, I can also go in the negative direction just by doing a negative spin. Okay, so 31 minus 360 is going to put me at negative 329. Okay, and if I did a negative spin and I still had a positive angle, I'd just keep doing spins until I got to a negative one, right? And these are just sample answers, right? I could have kept adding 360 degree spins, but there's the first two, the two that are closest to get to. Okay. All right. So, all right, and now this is a big concept, the unit circle. This is super important in trigonometry. So the unit circle is a circle that's centered at the origin at 0, 0 on an xy axis, okay, like this is, and it has a radius of 1, okay. So I'm going to put that into the picture. My radius is 1, okay. So I'm going to superimpose a 90 degree angle on this in standard form. So a 90 degree angle in standard form would look like this. Okay. So I'm just going to put theta here. Theta just means it's an angle. Okay. So there's my 90 degree angle. Okay. So that means that this would be 0 degrees right here. Okay, you could actually plot a 0 degree angle. It would just look like it would be a closed angle pointing straight to the right. And then this would be 90 degrees when, so I've got a 90 degree angle plotted there, okay? So each quarter turn is 90 degrees. That means that this would be 180 degrees. And if I added another 90, I'd be at 270 down at the bottom. And then if I get back around where the 0 is, that's also 360 degrees, okay? So those are the degree measures. I could plot any angle I wanted between 0 and 360 using these numbers on this in standard form. Okay. So let's take a sideways step for a minute. The circumference formula for a circle is 2 pi r. Or you could say pi times the diameter, but I want to use the radius here, so I'm going to call that 2 pi r, okay? Now for this particular circle, the radius is 1, so that means the radius of this circle is 2 pi, okay? Now there's another way that you can measure angles besides degrees, and that's called radians, radian measure, okay? And so here's how it works. The radian measure is going to refer to the amount of the circumference that an angle is cutting out. So if I look at this 90-degree angle right here, that's cutting out a quarter of the whole circle, right? So you could describe this angle by the actual measure, the degree measure, but you can also say, hey, it's a quarter of the circle, so I can describe how much of the circumference I got there highlighted by that angle, okay? So let's think about how much that would be. Well, if the whole circle has a circumference of 2 pi, that means if I go around all the way, I'll be at 2 pi. Okay, so this is actually 2 pi radians is the same as 360 degrees. So let's think about this, halfway to 2 pi. Well, if I went halfway around, then that means that this must be 1 pi over here. Okay, and if I'm going halfway to pi, which is my highlighted angle here, we'll write that as pi over 2, 1/2 pi or pi over 2, but we'll usually just leave it in terms of pi as a fraction like that. Okay, so each quarter turn then is going to be a half pi. So this is 1/2 pi. 2/2 pi would simplify to pi, right? And then this would be 3/2 pi, so 3 pi over 2, okay? And these are the radian measures at those different places, okay? So this particular angle, when I say that this is 90 degrees, that's equivalent to pi over 2 radians. Okay, so now it's really important. It's always been important that if you're talking about degrees, you put the little degree symbol. But now it's super important because we have got a different way to measure angles. And if you just say 90, that means 90 radians. Okay, so I wouldn't usually write out the word radians. It'd usually be written like this. But if you don't have the degree symbol, it's assumed that we're talking about radian measure. Okay. All right, so let's try. It's important to be able to convert back and forth between degree measure and radian measure. So let's try this out. So this says convert a 72-degree angle into radian measure, okay? Now I could plot a 72-degree angle, but I'm not going to do that. It would be somewhere up here, right, in that quadrant. But what I want to do is use, I'm going to use this as my conversion factor, actually. So as long as you can remember that 180 degrees is equivalent to pi radians, we can use that to convert anything, okay? So what I'm going to do on these problems is set up a proportion. So 180 degrees is to pi radians as 72 degrees is to I don't know how many radians, but now I can find out by cross multiplying, okay? So all of these problems, I'm going to say 180 degrees over pi equals something depending on the problem, okay? And since I had the degree on top there, I want the degrees on top there. Both my radians are on bottom. I guess you could flip this whole thing upside down, but you want to be consistent. Are you keeping your radians on top or your degrees on top, okay? So cross multiply then. Okay, so 180x is going to equal 72 pi. I didn't bother with the degree symbols because my final answer is going to be in radians, and I'm not going to have the degree symbol, okay? And then I'm going to divide by 180, okay? You could make a decimal approximation out of 72 pi. It'd be 72 times about 3.14, but don't do that. Leave this in, we usually leave it in terms of pi, okay? So those 180s cancel. And then I still want to reduce 72 over 180. And you could do that by hand, but just a quick refresher, since there's going to be a lot of reducing, if you just put that in one of these calculators, and then, so that's 0.4, which I know that's going to be, that's 4/10, which is 2/5. But let's say I didn't know it was 2/5. I could hit the math button and then change it to a fraction, first option, and then it's reduced. So change it back into a fraction, but now it's reduced. Nice little short way. So 72 over 180 reduces to 2/5, so this is going to be 2 pi over 5. So 72 degrees is equivalent to 2/5 pi radians. Okay? Let's try converting 30 degrees. So I'm going to use the same conversion factor. 180 degrees is to pi radians, as 30 degrees is to, I don't know how many radians, but let's find out. Okay, got it down to that, and then I'll just divide by 180. Okay, and I can reduce this one in my head. That's going to be 1/6 because it's 3/18, right? So this is going to be pi over 6. You could write 1 pi over 6, but you don't need a 1. I can see there's 1 pi up there, right? So that's pi over 6 radians, okay? We can use the same technique to convert in the other direction. This time I have the radian measure, but I don't have the degrees. But I'm going to still say 180 degrees is to pi radians, as I don't know how many degrees is to 7 pi radians. And then I can cross multiply. Okay? My final answer, it doesn't matter when you're doing the work, but my final answer is going to be in degrees. So in my final answer, I want the degree symbol, right? My final answer is in radians. I don't have the degree symbol. So be careful with that, okay? So I usually kind of wait till the end to decide to put in the degrees or not. But here, I've got pi times x is going to equal 180 times 7 pi. Okay? So let's see. 180 times 7 is 1260. Okay, and I still want to isolate x, so I want to get rid of the pi. And this is going to work out nicely because when I divide both sides by pi, those are just gone. So then I've just got 1260, and remember my final answer is degrees, so get that degree symbol in there. So 7 pi, and it kind of makes sense if you think about, well, if 2 pi is once around, you'd be going around 3 times would get you at 6 pi, and then so 3.5 times really, right? So 1260 would be 3.5 spins. Okay. All right. So let's try 2 pi over 3. We're going to convert this. This will sometimes throw people off just because we've got a fraction, but the method is just the same. 180 degrees is to pi, as I don't know how many degrees is to 2 pi over 3. Okay? All right, so I'm still going to cross multiply, like so. Okay? And so this seems a little more, well, it is a little bit more complicated, but when I want to isolate the x at some point I'm going to have to divide by pi. And when you do that, you could write this as 2/3 times pi, right? So those pi's are just going to cancel like that as well, okay? So x is just going to equal 180 times 2/3. Okay, so 180 times 2 would be 360, and then 360 divided by 3 is going to give me 120. So, I multiplied by 2, then divided by 3, and I got 120, and this is in degrees. Okay, on the next page, we're going to use our calculators to do some evaluating. So, going to evaluate the cosine of 3 pi over 4. Now, be careful here because there's no degree symbol there, right? So that means that this is radians, so that means I need my calculator in radian mode. Okay, so since now we have radians at our command, we're going to have to be going back and forth between radian and degree mode. So on one of these graphing calculators, mode is right there. You can see the third thing down. I've got it in degree mode right now. So I want to go down here, highlight that and hit enter. And then I'll go second mode to quit to get back to my home screen. Okay? And now I'm just going to do cosine of 3 pi over 4. And I'm going to put 3 pi over 4 as a fraction in my calculator. 3, and then use the pi button. Don't use 3.14 because that's just an approximation. Pi button's a lot better. So you hit second and then this little arrow up key to get the pi button. Divide that by 4. It doesn't really matter if you close the parentheses or not. And then I've got negative 7 point, well, going to the nearest, I'll go to the nearest 10. I'll call that negative 0.71. Oops, negative 0.71 roughly. Okay. All right. So let's try the secant of 8. Again, this is radians. Okay. Now we don't have a secant button. There's sine, cosine, and tangent. So what I have to do with secant or any of the cofunctions, the reciprocal functions, is I got to think, what is this the reciprocal of? So it's a co-pair with something, right? Where one of them has to have a co. So it's going to be the reciprocal of a cosine. So you can see the last section notes for a more in-depth explanation of that. So this is going to be equal 1 over the cosine of 8. So that's how I'm going to put it into my calculator. 1 over the cosine of 8. And that's going to put me at negative 6.87 roughly.